One of the cool things about a well-designed passive house is that details that look normal on the outside are actually much more complicated than they appear. Take for instance the slab foundation on this house. It looks like regular concrete, but it's actually a super insulated assembly. The in-facing brick ledge detail I first saw during the installation of the mud sill is key to this super insulated slab assembly. The plan calls for 3 2-inch layers of rigid foam installed right on grade, and 2 more layers of foam lapping over the brick ledge. This 10-inch thick assembly provides an R value of 50. Then, along the edge, 2 pieces of 2-inch foam are installed to create a sort of swimming pool liner that will encapsulate the concrete slab when it's poured. This edge insulation will also connect with the spray foam insulation that will later be installed in the wall cavity above. How did you come up with the number of 10 inches of insulation under the slab?
Well, the 10-inch number is actually derived from working closely with the Passive House consultant. In the planning package, if you can conceptualize a series of dials where we can turn up roof insulation, wall insulation, window performance, etc., the basement insulation or foundation insulation is one of those dials. And the insulation under the slab is probably the most expensive insulation that we put in the house. So it's the last dial to turn. So we max out the ceiling, the roof insulation, we max out the wall insulation, the windows are a certain amount of performance. We get to that basement and we just keep turning that dial until we get to a number that allows us to pass.
To get Passive House approval, an architect must team up with a Passive House consultant who uses computer software to model the performance of the house and determine the proper levels of insulation necessary to meet the Passive House standards. For Steve, this meant designing the assembly with a proportionate amount of insulation in the ceiling, walls, windows and doors, and foundation, which in this case is a slab. What would you say to somebody who feels like that's just overkill, that's way too much insulation under the slab and you're going beyond what you really need?
I mean, in some cases, I guess it's arguable that it is. But in the case of this house specifically, we're trying to meet a certain specific parameters of Passive House, and we're basically trying to get that plaque on the wall, and with that means ultimately at the bottom of the calculations we have to pass.
Now I know that the slab is the air barrier in this house, so weren't you worried about running mechanicals underneath it and through it?
Well, underneath it doesn't bother me as much as running them through it. We try and minimize what we run through there, but there's some things that are inevitable. I mean, plumbing drains, etc., have to go down, gravity flow. We have to team up with the town system outside, so they have to go below grade and they have to go out. So, you know, even though it is breaching our air barrier, one of the places I'm probably the least worried about is things that come through the slab. It's a pretty easy seal to deal with. There's not a lot of air movement across it like there is on an exterior wall.
And I suppose the subcontractors are pretty accustomed to running utilities under a slab anyway.
Yeah, the only thing I'm asking them to do here is maybe go a little deeper. So instead of just being inches below the slab, we're 2 feet below the slab. So they had to dig a little deeper trench, but everything's the same. The riser pipe got a little longer.
In addition to the mechanicals penetrating the slab, Steve spec'd 3 concrete piers to carry the load from the second floor, a design that raised 2 questions in my mind. Why piers instead of a bearing wall? And what about the potential thermal penalty?
One of the things I strive to do is get as much load to the outside of the walls as I can. Put all the floor loads, roof loads, etc. out there. So rather than doing a bearing wall, one, we tried to maintain an open floor plan with the house, which kind of negates the idea of a bearing wall. Mm-hmm. The open floor plan helps us with our heating and reduction in HVAC equipment, because instead of having 3 separate rooms that I have to target, I can target 1 large room. Much easier to move air around that way. And secondly, by having point loads, I'm able to pierce through the thermal boundary in the center of the building where the ground is at its warmest and where it's kind of the least penalty.
It was decided early in the building process to wait on pouring the slab until after the shell of the building was complete. So with the frame in place, it was up to the excavating crew to level the grade before the installation of the foam.
The day we walked in, the excavators were still here. None of the grade had been set. They had a dingo, which is a small gas-powered excavating machine, which is made for doing, going into a building and doing excavating in a tight area. There was a lot of confusion and a lot of people running everywhere, and actually the guy who did the concrete slab had to come in and kind of take charge and set them with a story pole. It's kind of what we do every day in this business. You can't, nothing's ever perfect, and you would like to come on the site and have everybody that goes before you be done. But unfortunately for carpenters, that really never happens. We're supposed to be the most flexible guys and be able to springboard and you know, MacGyver things and you know, just work around and in between and under and over everybody else.
I know there was some discussion about should we use 2-inch foam and build it up, or
Are you familiar with rigid board? It's foil
Yes.
face. I was thinking I would stack that.
Yep.
Okay. And to get my 10 inches of foam. Well, I found a company that made 6 inches foam and then 4 inches of foam. So I had my 10 inches without stacking it. So they had the footprint of the foundation. They cut it all to size for me, and then I dropped it in place. It was cheaper that way than it was buying 2 inches of rigid board stack.
Oh, really?
Yep. So it worked out well. It's faster and cheaper.
They give you a plan and they tell you where these different layers of foam are supposed to go. They don't tell you how to install them or how to prep them. So it was real fussy because once we had the grade set, the layers of styrofoam started with a 6-inch layer first, and that had to go in a specific orientation so that we installed the 4-inch layer on top of it. The joints didn't line up, so there was a lot of staggering involved. There was the second layer was perpendicular to the first layer. As we were putting the sheets down, if there was some unevenness, we used a new story pole to find out where the high spots and the low spots were. So as you put a sheet down, it didn't necessarily stay down. And all the penetrations, the piping that comes through the slab, it was very tedious layout because you had to drill through a 6-inch layer and then hopefully the 4-inch layer lined up the same as a 6-inch layer when you drilled the hole. So, you know, all the joints had to remain tight. You know, 2 different layers going on at the same time, and all the, you know, penetrations coming through the slab all had to be cored through the styrofoam in order to get that set properly. You know, some of the pipes didn't even come out of the ground. Some of them ran parallel with the ground, like per se the drain pipe. So we were able to just cut a notch in the bottom of the foam so it fit over the pipe that, you know, ran parallel with the slab instead of coming up through it. So we were able to fit the sheets together and just kind of, you know, trial and error, shake them out, put them together, make sure they're flat. If they weren't, we had to pull them obviously and do some more modification. The problems we ran into was where the pipes were supposed to be inside a wall, and if you didn't drill in the right spot, it would send the pipe off to the left or the right or front or back, and it wouldn't, you know, keep those pipes in line. We were able to oversize some of the holes, which we found made it easy because we were able to go back in and fill them with expansion foam after. Once we had the 6-inch installed, and then we had the 4-inch installed on top of that, there was 2 different layers of 2-inch foam that went around the perimeter as a base. We just ran those through the table saw, and we found that was the best way to cut them. And we basically just used a 16 common nail and stuck it through the 2 layers, and they were able to pretty much stand on their own.
The last step was to install a continuous layer of 6mm poly and integrate it with the sheet of poly that was installed as part of the mudsill assembly. Besides being a secondary air barrier, Steve, as usual, had an altogether different reason for this sealed layer of poly.
In this case, we put the poly down on top of the rigid foam. Sometimes I see it drawn below the foam, but through experience, I learned that foam floats. So if you don't put that poly in and you just go and pour the slab over the rigid foam, it won't take long before you have icebergs start popping up through your slab.
One of my favorite things is being on the job site and meeting great craftsmen. And when it came to watching the slab being poured, I wasn't disappointed. John Lopes and his sons are true masters of their trade, and watching them work on everything from using a pump truck to direct the flow of concrete, to lifting the wire mesh into place, to using a story pole to establish the height of the finished slab, I was impressed. All the way down to the finishing touches, this team made a tough job go quick and look easy. Next time, we'll rewind a little in the process and learn about the design behind the framing of this passive house and how the carpenters built it.